Consider the following graph, y equals f. So this is graph of f. So here is the origin. Let g is definite integral 0 to x of f, and h is a definite integral negative 2 to x. So x is variable, by the way, and x could be anything bigger than or equal to negative 3. In part A, find the critical numbers of function g on the interval 0 through 8. So 0 through 8. So here. So the new function g, let me write here. Here, g is defined as the definite integral 0 through x of f. Okay, so critical numbers are related to first derivative of a function. So we need to find first derivative of this function g, and where the derivative is 0 or undefined, the x values where the derivative is 0 or undefined are critical numbers for the function. So let's find the derivative. So when we find its derivative, so we are finding derivative here. That derivative will cancel this antiderivative sign, this one and dt together. By the fundamental theorem of calculus, when we take the derivative, only the function, this function survives and picks up this variable x, fx, and this is constant, so we just ignore. So the derivative is simply this function. Now we set the derivative 0 to find critical numbers. That means derivative 0 means the function is 0. So we want to find where the function is 0 on this interval 0 through 8. So here, if we look at this graph 0 through 8, this is the graph y equals ft. It's 0 here. Okay, so that is when x is 0. Sorry, x is 6. And this is a straight line. So the function is defined everywhere on this interval 0 through 8. So only x equals 6 is the critical number. Is the critical number of g. Okay, that's part A. Now part B, we need to evaluate three things: h6, h prime, h double prime, and h is defined here. Okay, so let me copy over here. So h is given by definite integral negative 2 to x of f prime dt. Oh, this is ready to do the antiderivative. So antiderivative of f prime is just f. Okay, that's simple. Okay, antiderivative of some derivative means derivative and antiderivative cancel, just ft. By the fundamental theorem of calculus, now lower limit, upper limit, negative 2 and x. Okay, it's kind of hidden, we don't write, but this variable is t. So this is t equals negative 2 and t equals x. Now we evaluate this function, f, replace t by x, so fx minus f t by negative 2, f of negative 2. So hx is, in fact, f of x minus f of negative 2. Oh, f of negative 2 has a value. If we look at this, so let me, here's this one. Now let's find the value of f of negative, sorry. Negative 2 is here, and the function value is here, which is 2. So this value is in fact 2, so we can replace that. So this is simply f of x minus this one is 2. The function value at negative 2 is 2. So that's h of x. So let me write one more time. That is, we just found h is in fact, when we worked out, this is f of x minus 2. Now we need to find, if we go up, we need to find h of 6, h prime 6, and h double prime 6. So now let me put number 1. H of 6 means replace x by 6. F of 6 minus 2. Now we need to find f at 6. Looking at the graph, f at 6 is here. That's at the level of x-axis, so the value is 0. The function value at 6 is 0, minus 2, so negative 2. Next, we need to figure out h prime of 6. So that means slope of h at 6. And so our function is given in this way, by the way. So h is pretty much the function minus 2, okay? Just this function shifted 2 units down. So to find h prime 6, we need to find derivative first. So let's not write this way. So we need to find derivative first. Let's find the derivative. So h prime means find the derivative of function f prime minus derivative of 2 is 0. So h prime is in fact just f prime. That means our question is h prime at 6. So h prime at 6 is now f prime at 6. So derivative of the function at x value 6. So we need to go and check. So what is the derivative of this function at this? So derivative means slope of the curve. In this case, the curve is a straight line. So the slope at 6, we can take, I don't know, as rise over run. The slope of a line is just, okay, this is run, 2 run, 6 to 8. The rise is negative downward. Okay, this is rise over run, so negative 1 over 2. Simply this one is negative 1/2. The slope of this line is in fact negative 1/2. Okay, and we need to find h double prime of 6 in the question here. So first we need to find second derivative. Look at the second. H prime is f prime. If we take derivative one more time, h double prime is f double prime at x. Okay, this implies we are trying to find h double prime at 6. That means second derivative at 6. So this function is a straight line. Around 6, the function is a straight line. First derivative will be its slope, and then derivative one more time is 0, because for a line the second derivative means concavity. There is no concave up or concave down, it's 0. Or second derivative from this work, the derivative of first derivative at 6. First derivative is negative 1/2. That means if we take derivative one more time, that's 0.